Algebra 1, we are today in 12.7. We're looking to divide some radicals. So a couple days back I had a mini discussion on this and said we do more another day. For dividing things, you can either do the roots first and save the dividing for later, or you can do sometimes division first and save the root worries for later. What I would recommend is if you have any problems where you can do any division, I would do the division first, because you've just been dividing for a lot longer time. You've been dividing since elementary school. You've only been doing roots for like a chapter. So any problem where you see the ability to divide, I would look to do that. So I'm going to take a quick walk through, and you have a sheet of notes that matches the problems on the board. I'm going to just do a quick walk through, and any that I see a division I can do, I'm going to do it. Okay, so 2 can't divide 3, 3 can't divide 5. Okay, but 40 can divide 10. A root dividing a root can make a new root if you just divide the radicands. 40 divided by 10 can make a new radicand of 4, and that problem is going to be easier to manage. On this, 6 and 5 can't divide each other, but 2 can go into 6. So I'd leave the 6 and 5 alone. 2 into 6 goes 3, but leave that under the radical sign because originally they were radicals. They should still be that way. Here I can divide. 12 can divide 4 to get a 3. The root can divide into the root to make a smaller root. 6 into 42 can go 7. This one I can do a division. The 5 can go into the 20 to leave a 4. The x can still sit there. And anytime you're doing fraction kind of things and you eliminated the top, always remember there's a 1 there. This I could do some work. The 28 can divide the 4 to leave a 7. The x squared could divide the x to make an x. Remember, when we divide, we subtract powers, and that has an invisible 1. The y's, there's one more of them on the bottom, so for the y's, I could leave a y on the bottom. And then I'm kind of out of luck on the rest of those for that. But a lot of the problems, you can make them easier at the beginning by trying to divide anything you see that can divide. The normal numbers can only divide the other normal numbers, the coefficients. The radicals can divide the other radicals to make some smaller radicands. So we're that far. Then we have one other rule, 2 notes on the paper that you're holding. One of the main rules is you're just not allowed to have roots on the bottom. Roots on the bottom have never been allowed. So any of these problems that right now have roots still on the bottom, we're going to have to address that. And the way we're going to address that is we're going to multiply the bottom and we're going to multiply the top by some number we'll choose to make the root go away. A problem like this, an alternate way to write this would be like that. So whether you see the problem written this way, it means this. This problem means this. Right now, these problems are all breaking the rule that I just said. This has a root on the bottom for sure. This one does too. It's harder to see it when you look at it this way because this is a little deceptive. But this means this. This has a root on the bottom. So what we're going to look to do is we're going to multiply the bottom by something that will make the bottom no longer be a root. If you have a root 3, the best thing to multiply that by is another root 3, because we learned, I think it was yesterday's lesson, root 3 times root 3 makes normal 3. And now that's going to meet the rule of we're not allowed roots on the bottom. This is called rationalizing the denominator, is the official mathy title of this. In fraction land, always, whatever you do to the bottom, you do to the top. On top, root 2 times root 3 is root 6, and that's an answer, and that's done. You cannot divide the 6 by the 3, because the 6 is a radical kind of number, the 3 is not. Those cannot interact. That's just it. This problem will do the same approach. I'll multiply the bottom by root 5, so that I get a regular 5. And that'll be my best answer. The top, I'll also multiply by root 5, because in fractions, that's just how we've always been. Whatever you do to the bottom, you do the same to the top. These multiply to make root 15, and we're done. You fight off the urge to divide those, because this is a radical number, and this is not, and those can't interact. Square root of 4 is one of our perfect square superstars. Square root of 4 is just 2, and on we go. This has a root on the bottom, so we're going to multiply by root 3 on the bottom, and we'll multiply by root 3 on the top. On the bottom, root 3 times root 3 is 3, but the 5 also is multiplying in there to make a 15. The top would have a 6 still, and a root 3. And I actually circled that a little bit too soon, because that is not my best answer. 6 and 15, that's a fraction that can reduce down to 2/5. We would want to make the 6/15ths the 2/5, but the root 3 is still around. This one, we multiply by root 7 on the bottom. So that's a normal 7. Multiply the top by root 7. 3 can't multiply root 7 because normal numbers can't multiply roots. Just put them side by side, and that's as good as we're going to get on that. For this one, we would like to multiply the bottom by root x. So we multiply the top by root x. On the bottom, root x times root x is normal x. On the top, the root of 25 is a perfect square superstar. That's 5. And just leave the root x up there, and we're good on that. Powers, a day or two ago with powers, we were looking to cut the powers in half. So if I have an odd amount of powers, I'll always multiply by one more of those and match that on the top. On the bottom now, we have x to the 4th, and we can cut that in half down to x squared. The top would have the 7 and the root x. This, I feel like doing the root 4 superstar. The square root of 4 is 2. And then I can multiply by a root x in both locations. So the top has a root x. The bottom still has the 2 from rooting the 4. And root x times root x is regular old x. This I would need to multiply by root y's. So my answer on the bottom would have a regular y. Anytime you do a root times itself, it just erases the radical sign. It just gets you the radicand without this radical sign anymore. The top has a root because roots can multiply each other. And then we're good. If you have adding or subtracting on the bottom, you're going to have to multiply by a thing called the conjugate that you've never heard of before. The conjugate is just a fancy way of saying use almost the same item, but switch the sign. Remember, the bottoms and the tops of anything fractional, if you see adding or subtracting, they're in parentheses, they're invisible, but the parentheses are there. So if you see something that's adding or subtracting with roots on the bottom, what you're going to multiply by is, again, called the conjugate. It's like not an identical twin, but a brother or sister. Copy what you had, but the sign changes. On the top, we have a distributive problem to do. 5 times 2 is 10. 5 times root 3 would be 5 root 3. Get the minus in there. On the bottom, we're going to have to FOIL, but not completely, because the way we picked this conjugate, the reason we picked a conjugate is to get some nice eliminations. This is a crazy 2 root 3. This is a negative 2 root 3. The positive 2 root 3 and the negative 2 root 3 will eliminate each other, and that will always happen. That's why we switched the sign, was to get that sort of elimination. So don't worry about this. Don't worry about that. They're going to self-eliminate. Worry about these making a 4. Worry about these making a normal 3. Root 3 times root 3 is normal 3. Since the signs are different, that's a minus. 4 minus 3 is 1. I refuse to ever write 1 on the bottom of a fraction that doesn't even need to be a fraction. That's just the answer. So do that again, same way. We have adding or subtracting on the bottom, make an almost identical twin, but take the sign and switch it. Whatever you do on the bottom, you do on the top. This top will be a distribute. 8 times 5 is 40, plus 8 can't multiply roots, so just write 8 root 11. On the bottom, I don't care what this is, it's negative. I don't care what that is either, it's positive, the same item. This and this will self-eliminate. These will make a 25. These will make a normal 11. The signs are always different, so it's always subtracting. That's going to be a 14. This answer I can make a touch better because the coefficients can all divide by 2. I will divide all the coefficients by 2. I won't touch the root, but I'm going to divide all the coefficients by 2 to make that better if I can. This, I'll continue to do the conjugate. Always the focus is on the bottom. Almost the exact same item to multiply by, but switch the sign. Top, we're going to have to FOIL. We're going to get a root 10 minus root 14, a plus root 15, a minus root 21. I should think about whether the superstar numbers can help me there at all, and they are not able to. On the bottom, I don't care what this is, it's positive, I don't care what that is either, it's negative, that'll eliminate. 5 times 5, root 5 times root 5 is a normal 5. Root 7 times root 7 is a normal 7. Always a minus there, because the signs are always different, because we chose that. 5 minus 7 is negative 2. And that's what we do with that. Last one, same style. Okay. I'm going to do a group of parentheses with 4s and 3 root 7s. But since this had a plus, I'm switching signs. Top, I'm going to have to FOIL. 2 times 4 is 8 with a root 3 along for the ride. Multiplying these is a negative 6 for the coefficients and a root 21 if I multiply the radicals. Negative 5 times 4 is negative 20. Negative 5 times negative 3 is positive 15 with a root 7 along for the ride. Don't care what this is because it's positive and that's the negative balancing eliminating item. I do need to do 4 times 4 is 16. I need to do 3 times 3 is 9. Root 7 times root 7 is normal 7. But 9 times 7 is 63. Minus, because the signs were different, 16 minus 63, that's negative 47. And that's the best that I can do because there's nothing that can go into all of those numbers. If this were an even number and this were an even number, I would have divided every beginner number here, the coefficients, I would have divided them all by 2, but that's not even close to happening. Homework off of this is 518. The only slight difference I notice on any of these, beyond anything that I did, there's a couple problems again where they throw a negative on the problem. So you can just throw a negative on the answer. So if you see some negatives on there, don't worry about that. You can ignore the negative until it's time to just make sure you remember it for the answer zone. Email me if you have questions. That's it.